Okay, thank you very much for coming. I'll start with a little bit about who I am. So I'm Mike, hi. I'm also known as AppSecBloke on Twitter. I'm quite active on Twitter. Yeah, thanks. I do tweet a lot and about all sorts of things. It can be anything about current topics, current events in information security. I do engage in quite a lot of debate around some sensitive topics, like why we should have a fully HTTPS web. I firmly believe we should. There are others that don't agree with that. And I can get a bit grumpy about it from time to time, generally in a good-natured kind of way. I write blogs. I'll come on to that in a little bit more detail shortly. I blog as AppSecBloke. And I'm also a helper, so I recognise a few people in the room. I take a great deal of pleasure from seeing other people flourish and develop, and I like to get involved with that in a selfless way. I just think that there are good things in good people, and I like to help draw that out. Excuse me. I'm also a speaker, as you can probably tell. It's a bit of an interesting journey for me. My first ever information security conference was BSidesMCR, and last year, 2017. So I turned up completely out of the blue. I'd never been to a conference before in this industry, just as a punter. And a bug kind of caught me. And I felt really at home, felt like I was part of a community for the first time. I've been involved in the information security industry for a number of years, but I just felt like a guy that works in a company that does the security thing. And I never really had the opportunity to reach out to other people. And this conference was the first time I had that opportunity, and it made me feel great. It kind of influenced me in my decision to get involved in blogging. I came right out of this conference, set up a blog, and wrote a review of this conference. And that I tell the world what I thought of the conference and how it made me feel, and I felt it was a life-changing event. It then encouraged me to become a lot more active on Twitter. I befriended a lot of the people that had delivered talks here or who I'd met here, and we've now become really good friends as a result of that. And then I thought, actually, I've now been blogging for quite a while. I'd like to take the message out in a less static way. Reading my words on a blog are one thing, but me being able to go out and give actual verbal experiences or testimonies about my experiences and what I've done, I think can be more impactful sometimes. So I made the decision back end of last year that I really wanted to get involved in talks, and I thought, well, I enjoyed OWASP so much, I enjoyed BSidesMCR so much that I was encouraged to apply for BSides Leeds. Didn't go, didn't get it, I beg your pardon, but went along nonetheless. Really enjoyed the conference. One of my colleagues in the audience came along with me. I think he'd echo the fact we had a really good time. But I wasn't put off. I did get invited to do a lightning talk at the event on the night before the conference. I then applied for BSides Scotland in Glasgow. I didn't get that, but I was offered a reserve speaker position there, which was great because I was invited up there and I was treated as if I was part of the crew delivering content on the day. Again, met some great people, and again, had a really good time at that conference. Again, it didn't put me off. I continued, and then I put a speculative application into BSides London, and I actually got that gig, and that was in June this year. That's the talk I'm going to be giving for you today. So I went down to London, gave the talk, really enjoyed it, and that was it. I'd done it. Broke my duck, and now I'm really, I really feel like I'm part of the scene. I did a talk for OWASP in Manchester last month, and that was really good. This talk once again. Meanwhile, I had an application in to speak here, but hadn't heard anything. And on Twitter, I started seeing people going, "Yeah, I got my talk accepted at BSidesMCR." And I thought, well, I haven't heard anything, yes or no. Delivered the talk. It happened that Mark, one of the organisers of BSides, was at that talk. At the end, after questions were answered, he said, "This isn't a question, it's more of a statement. We'd love you to come and talk at BSidesMCR." And that was pretty much, it was the best moment of the year as far as I was concerned. Because what that meant was I'd gone from attending as a punter at a conference, just happened to be this one, to being a speaker at the same conference within a year. And I feel really, really privileged to be here giving this talk for you guys today. So I'm an InfoSec guy at an ISP, a local ISP. Won't mention the name, but tell you about who they are afterwards. And I'm also a member of OWASP. So quick show of hands, who's an OWASP member? 1, 2, 2. Okay. you can keep your hands up because you'll know. But a show of hands if you know what OWASP is. Okay, quite a few more of you. For those that don't know, it's an open web application security project. So it's a global foundation of application security professionals and academics that come together and share great experiences, do good things, get good projects off the ground, and bring that back out for the greater good. There's been a lot of debate on Twitter, which I've been actively involved in, around its reach out to getting new members. And that's quite indicative of the two hands, three, including myself in this room. They're not doing a good enough job of getting the message out and getting people back in. And I think that's been acknowledged at the board of director level. And they're going to do a lot to try and make a difference there. I'm a paid member of OWASP. So the two guys that's put their hand up are you paid members of OWASP? So
the chapter is run jointly with the BCS, so I go in as part of that.
So you get a part of the BCS. So being a paid member would cost you $50 a year as a professional, an individual, about £35. If you're a student, it's $20 a year, which is about £15. For that, you get to contribute money into projects. Chapters then get money back so they can put nights on, so they can put talks on, and then share a lot of the knowledge and experience that's happening more local level. But what you get in return is pretty cool too. So for your £35 a year or £15 a year, you get an OWASP email account. Now that's pretty cool. You get a michael.thompson@owasp.org email address. And I kind of like that because it adds a little level of authenticity to you as an InfoSec person. So I've consolidated down a lot of email addresses I would have used previously to communicate with people. And I just now use my OWASP account. That's kind of handy. But you get a G Suite account as well. Now, that's pretty good. G Suite account is a cool thing. It's a really expansive set of Google tools, including mail. But you get unlimited storage with it, which is not a lot of people realize. OWASP has somehow managed to negotiate with Google to get this huge, vast, endless space of storage on their network, on their platform. And so you can use that to put anything. There's no restriction on what you use it for, and it's endless storage and endless cloud storage. And you also get the benefit of feeling that you're contributing to something that's pretty cool globally. But again, there's a lot of work to do within the foundation to attract new members, and I think that's something they recognise and want to do something about. I'm going to skip that one because it's a bit boring. Okay, why are we here? So, who knows what a web application firewall is? Okay, pretty much more or less everybody in the room. Who's got one? One. A few people. Skewed figures here because some of the people in this room work with me, but not too many people. Okay. What is a web application firewall? A WAF. So it's a layer of protection between your software on the web, your assets, and the bad guys. And therefore really a layer of protection against intrusion into your data via your web applications. So we're thinking OWASP top 10. Now every 3-4 years, OWASP get together and they take data in from the world. So what kinds of attacks are people experiencing? And they put all that data together and they'll produce a top 10. Now, it can be misleading. The top 10 isn't the only 10 web application vulnerabilities that are out there. But these are the ones that are considered to be more common, easy to execute, impactful, and have really severe consequences if there is an exploit. So we have a top 10. Typically, you'll see in the top 10 at number 1, injection. So SQL injection, command injection, and so on and so forth. Things that allow an attacker to modify an underlying database or an underlying operating system. That's at number 1. It's been at number 1 as long as I've been involved in information security. And then you get other things like broken authentication, so things like having cookie theft and hijacking, session hijacking and all that kind of thing. Then you have things like cross-site scripting. Cross-site request forgery has gone out of the top 10 recently. It's been kind of merged away because there's a lot better mitigation. But those are the examples of the kind of threat that the OWASP top 10 talks about. And they're the kind of things that a WAF will provide protection against. In the way we've implemented it, it's also a method of controlling access to your web applications. So we control the DNS of everything that we have on the web. And by doing that, we're able to steer traffic to wherever we want it to go. I'll come on to that in more detail in a bit. we're able to monitor a lot more. Again, I'll talk about this in more detail, but we've gone from a position in the past of not being able to monitor much to now being able to monitor practically everything. So, and it's a legitimate component of your web app arsenal. So you hear again on Twitter, I get grumpy, where people say, well, a WAF is purely a compliance tool. Okay. It's there to say our apps are secure. Nothing of the sort. It's not a compliance tool. It's there as a layer of protection. Okay. It's there in the same way that server hardening is important. It's there in the same way that secure coding is important. It's got a legitimate role. So what WAF isn't, it's not a total solution. So I touched on that in the previous slide. It's not the be all and end all. It's not a way of saying, well, we've got a WAF in front of everything, so everything behind it is cool. It certainly isn't a reason for devs to say, well, whatever, our software can go in whatever condition we choose because the WAF will protect it. And I'll give you a little anecdote. The anecdote is that we've got a fairly big dev team where I work and quite a large architecture team. And not many of them really, if any, know what the WAF is doing. Okay, they know it's there because we've done this kind of talk for them, but we've not gone into explicit detail about what it's protecting against. But there's a reason for it. It's quite deliberate. And the reason is that while they're not entirely certain of what's happening in front of their software, they're not encouraged to be relaxed about securely coding it. It keeps them on their toes. And I work very closely with developers around secure coding. So we're kind of bringing that all together into a kind of a harmonized approach to securing our stuff. It's not an excuse not to patch. So we see a lot of the breaches that have happened in recent years, in the last 12 months, have been around not keeping software frameworks up to date. So we know that Equifax got attacked via an obsolete version of Apache struts. Okay, patch was available several months ahead of the attack. They knew about it, but they did nothing about it, and they were attacked. A WAF might have prevented that because it wouldn't have been able to access the underlying framework. It's not an excuse not to patch the stuff, though, and keep your components up to date. And it ain't an opportunity to turn around to your boss and go, yeah, we've got a WAF, guys. WAF's there. It's doing stuff. A pay rise. We've made improvements to the WAF. Can we have more money? It's not that sort. So how did we arrive at this enlightenment? Okay, well, we'd had a bad number of days, actually. In autumn 2015, September 2015, we were taken off the internet for about 2.5 to 3 days. And that wasn't just our website, that was our entire platform. Marketing website, customer portals, diagnostic systems, contact systems, everything had gone. We were suffering the biggest denial of service attack that we'd faced as an organization in the time that I've been there. So that was a mixture of TCP SYM floods, okay, UDP, and HTTP attacks. We were being attacked by pwned WordPress setups. They were pretty easy to mitigate against because that was HTTP and we were the web guys. We could see that and do stuff with it. But the TCP and UDP, that was network stuff. We were really vulnerable to that. And we dealt with it, but we dealt with it in what didn't feel like a sophisticated or repeatable way. And that didn't feel good enough. So we needed to do something about it. So we had a bunch of meetings, and this was even board level. And the message was, we can't have this happen again. We can't have a repeat of this. We need our critical web apps up. We're an ISP. If we're not on the internet, that's not very good, is it? It's bloody rubbish. So we need to keep our critical web apps up. We need to block malicious requests. Pretty obvious. We need to stop access to our origin servers. At that point, if you DNS'd, you got the back-end IP anyway. So if we did any kind of obfuscation of the DNS, if you knew the IP, you could still kill the server. And that was going on. It's part of the reason that we had such a problem. We need to have eyes on everything. We need to be able to monitor everything that's going on. We couldn't see much. We can now see lots. And gain a better understanding of our traffic. So where is it coming from? Are we getting a lot of traffic from the UK, where our main customer base is? Are we seeing a lot of traffic from Europe, China, Russia, the USA? We had no idea, really. We didn't have any understanding of geo-IP. So we were already using some technologies in pockets of the business, but kind of only in proof of concept. So we had a project that we kicked off that was get off the proof of concept plan and get on to delivering as a production solution. So we decided that we were already using AWS, Amazon Web Services, to deliver certain solutions to customers. So why not do some of that ourselves? Why not reverse proxy connections to our websites via a proxying system so you don't ever see the origin web server? Okay. Why don't we look at IPs as they come in? We currently trust all the IPs that come in until they do something bad, and then we retrospectively block them on either a web server or on a firewall. Didn't seem elegant and didn't seem something we could do repeatably. Request routing. So what if we get an attack from a particular country? What can we do about it? Okay, we'll come on to that. Screener request. So what do our requests look like? What's in the user agent? Well, we kind of could see it if we looked in an IIS log. What's in the URI? What's in the body of the, what other things are coming in the body? We had no idea really. We could only look again after the event. And we needed to handle a request. So what if a request contains something we considered bad? What can we do about it proactively rather than go, oh, that IP tried SQL injectors, right, let's block that IP until they come in with a different IP. And we needed better monitoring. So our technological approach was to use Route 53, Amazon's native DNS infrastructure. Very powerful. I'll show you why in a bit. Elastic load balancing. So we need something that's not ours to take care of DDoS and large load, huge volumes of traffic. Not strictly speaking anything to do with WAF, but because we're using Amazon, we can benefit from their certificate technology. So in the same way, if you use Let's Encrypt, you kind of set it up and it auto-renews forever. With us, it's the same. You set up our certificate management in Amazon and it auto-renews forever. And we've got a lot of certificates. We talked about reverse proxying. So we use Nginx. Interestingly, our predominant technology stack at our company is Microsoft and ASP.NET. When you hit us, you hit an Nginx proxy. And so you're going to get a kind of Linux thing, but a bit of an ASPX page coming back. It's a bit weird what these guys are actually doing. So we like that because it's not clear cut what technology is sat between an attacker and us. We're using IP block lists. Again, let's give the work to somebody else. So we call out to published IP blacklists. And if we see your IPs, we do stuff with it. Other technology. That's always left in because we've got something new every time, and I don't want to be keeping up updating this. We use our actual web application firewall is this thing here, NAXI, and it stands for Nginx Anti-Cross-Site Scripting and SQL Injection. Okay, it's not signature based; it's pretty adaptive. It's open source, and there's a theme. We'll get to that towards the end. OWASP top 10, everything in it and beyond is in that module, and it works with Nginx. And fail to ban, that does things with you when you've been doing things bad, and I'll come on to that again. And ELK. So anybody know what ELK is? Show of hands? Quite a few people. So it's pretty cool. Skewed again, because these guys. But yeah, Elasticsearch, Logstash, and Kibana. So it's a really neat way of taking logs from whatever generates a log. So it could be a web server, it could be an event log, an error log, Route 53's DNS, etc. You stick it in a big log pile, and then it can be indexed really easily into a uniform pattern, and then Kibana allows you to build some really neat analysis tools. Okay. So that's a stylized diagram of what it looks like, but I'm going to skip this because I'm pressed for time. I'll give you a real rough diagram. Couldn't be bothered drawing this, and you can probably appreciate why. So that's you on the internet. So you make a request to one of our websites, and you're good. You're not misbehaving. So you hit Route 53. Route 53 does a health check on the site you've requested. If the site is, for instance, dead, then it will take a look at your request, process it, and send you down to a static stack here, which says, sorry guys, website bust, we're on it. Come back another time. If you are a UK person or Ireland, Isle of Man, etc., come through here, we do the health check and the site is up. We say, where are you coming from? And you send you down here. And ultimately you'll get served web stuffs from here. If you're from outside the UK, we do the same thing, bring you down here, and we send you to this stack. So you remember me mentioning about being able to control how we direct traffic to places? Well, this is it. We do it at Route 53 up at the top here. If you are doing bad things and say you come through here and we recognize down here that you're on one of these lists, that includes Tor, exit nodes, and a bunch of other things, we drop your connection on the server, so you never get near the web servers here. We drop your connection here, and it's basically you'll get a Chrome connection error. Okay. If you are not on one of these lists and you make a request that contains SQL syntax, then Nginx NAXI on here will go, aha, SQL syntax. I'm going to block you with an HTTP 418. Anyone know what one of them is? It's a teapot. Okay, there is an RFC. It's a genuine HTTP status code. Google recognizes it. And we put you on a list in failed to ban that says, I found you, but you get a 418. If you repeat that 3 times, you get your final 418 and you get put on a ban list for 4 hours. Okay, we made some changes since this last talk, because there might be a few people in the room that remember we did it a different way, which was to ban your first time of asking for life. I took away that was a bit strong. So that's what we do. Okay, and then 4 hours later, your hacker comes back and he gets 3 more attempts, 4 more attempts, he's down again. Okay, did you want to ask a question?
Yeah, if you don't mind. So you're blocking Tor exit nodes.
Yeah.
We used to do that, but I found recently that there's a lot of people that are using Tor exit nodes with legitimate DNS services.
Yeah.
So you have a choice. Do I now block potentially legitimate DNS traffic?
Yeah.
Because it also happens to be a Tor gateway.
Yeah.
Or not? I'm
Yeah.
interested in what approach you took to that.
Yeah. Well, the quick answer is that originally there were 2 types of user using Tor: an attacker, in which case we're not bothered, or a security researcher, in which case a security researcher we'd think would understand that we were taking this approach. But it's just a list where we think the 80-20 rule, we think the majority of people coming out of Tor are probably doing something that we're not interested in. So it might be security research, in which case we'd hope you'd be sympathetic. But the chances are you're probably going to be an attacker, in which case we don't care.
So you'd throw away the legitimate DNS traffic at the same time?
Quite likely. Well, we would at this time, at this moment, but it's a good point. Okay, so that's pretty much how it works. Okay, now what you see here is that there's a perimeter, a dotted line perimeter. Everything inside there is in Amazon Web Services, everything. And for every single box, I forgot to mention the honeypot here. Yeah, what we do is when we process a bad request, we send you to a honeypot here. So you do get a 200, and if you're running a script-based attack for certain things, then you can knock yourself out, because we're just going to see your traffic, but it's going to sinkhole into that server there. But we monitor it. For every single entity in this diagram, it generates a log, every single thing, including down here on premise. And they're all dropped into Elk. So again, we've got a ton of stuff coming in, and we're able to keep an eye on it. So, wrapping up. What we're getting, so we can modify, we can ban modified requests, we can handle them far better with Teapot and Honeypot them. We've got an external bot list that we manage. Again, it might not be perfect, but 80-20 rule is we kill the majority of them that are bad. We drop dodgy IPs. We look at user agents and we get rid. You can't hit our origins anymore. It's a big win for us. Countries considered a threat are easier to disallow. Afterwards, if anyone wants to talk more about that, come and grab me, because there is a bit of devil in that detail. We see all the HTTP traffic. We get free cert management, and we keep our websites up. So spoofing and VPNs aren't easily handled, but we do look at other things. We look at your request itself. So we can see your user agent, we can see your HTTP request, and we can handle it. We still do a bit of manual work, so whitelisting and things like that. Bad rules can break your apps, so we've got to be mindful of that. We've no machine learning or AI. It kind of comes on and off our agenda. Currently, it's kind of off our agenda. We need to keep up because new threats need new analysis. It's always a game of catch up. So in conclusion, WAF isn't a total solution. I think I made that point clear. It's part of a broader, deeper approach to security. It is as valid as hardening a server. It is as valid as good network design. It's as valid as secure coding practices or good secure coding practices. It's a first-class member of the layered security family. So thank you very much. Finally, and I'll take questions afterwards. I'm AppSecBloke on Twitter. You can come and see me. I do a lot of stuff on there. I'm a member of a thing called the Beer Farmers. It might be worth following me just to find out about that. There is a member of Beer Farmers staff in the room.
Head of security.
Head of security. And we're all about security, right? And shit posting. And my blog is appsecbloke.com. Okay, so again, thank you very much for your time.